Now the point is that when we say that there is a significant amount of skewness in data, a significant amount of positive skewness or significant amount of negative skewness in data, in this case what exactly skewness means for us, means these numbers what exactly they try to convey to us. See, in this case, first it is telling us that there is a positive skewness in data because this number is positive. Had it been negative, we would have said that there is a negative skewness in data. So it means what? It means that most of the trucks are being sold over the average value, and average value is $94,000. So most of the trucks are being sold above the average value, and this is because we are having the positive skewness in data, and whether this deviation from average value is significant. So for that, what you can do, you can divide 2.567, that is skewness value, by its respective standard error, and it is going to give you the significance level of skewness. If this value is more than 1.98, so we say that there is a significant skewness at alpha is equal to 0.05 level, and if this value is more than 2.58, so we say that there is a significant skewness at alpha is equal to 0.01 level, and if the skewness divided by its standard error ratio is more than 3.98, so we say that the skewness value is significant at alpha is equal to 0.001 level. So we generally make our conclusion at 95% level, 99% level, and 99.99% level, and corresponding to them we are having the three key markers, that is 1.98, 2.58, and 3.98. They are all the Z values. So just keep this in mind for the time being, that if the ratio of skewness divided by its standard error is more than 1.98, there is a significant amount of skewness. So what is this scenario? And you can ask me why we should talk about this significant skewness or significant kurtosis. The point is that, see, suppose we are having a comparison between different type of cars, and one company is beating drum that okay, we are selling this significantly large number of cars at higher than the average price. Or suppose in the same company there is a competition between different branches or outlets of that same company, same brand, and one outlet A says that okay, we are doing significantly better because our salesmen are selling the cars at significantly higher price, higher than the average price as compared to say outlet B. So in that case, what you can see, what you can tell that as a statistician, I'm going to prove that first whether you are significantly selling at higher than the average value, and then we are going to make a comparison between these two groups. So for that we can use the significance value of skewness and kurtosis. So in that case, what you can do, you can now use your calculator and divide the values by the standard error to find out whether there is a significant amount of skewness or not. So it's a 2.567 divided by 0.427. So it's a 6.011. So it's a higher than our all the three cutoffs. That is, last was for 3.98. So we can say there is a significant positive skewness in the car sales prices. So it's a significantly positively skewed data. The variable sales is a significantly positively skewed variable. So yes, most of the trucks are being sold at a significantly higher than the average price. And is this the same scenario for the automobiles? So in automobiles again you can see there is a positive skewness. So it means even the automobiles are being sold at a significantly higher than the average price, but we can make a comparison, means who is doing better. So if we again calculate the ratio, that's a 2.156. So 2.156 divided by 0.253. 253. So it's 8.52. It's again highly significant. So it means what? Both automobiles and trucks are significantly selling at higher than the average sale price. What about the resale value? So whether resale value is also higher than the average for both automobiles and cars, you can say yes, it is. So it's again positively skewed, and again positively skewed for both automobiles and trucks. So that's how you use skewness and kurtosis stats for deriving meaningful observations.